Council. And we have with us a very special guest, Barbara Imhof, a space architect. And through this webinar, our aim is to present to our audience how space is not just for rocket scientists, but it's for really everyone, women, men, whether you're an architect, an artist. And she's going to present to you how space is really an interdisciplinary platform. And so moving on, firstly, I will present to you what the SGAC stands for. So the SGAC, Space Generation Advisory Council, it's an organization which is part of the United Nations, and it represents young space professionals as well as students, and represents us with the United Nations and space agencies such as NASA and ESA, and gives a voice to the young generation in reaching out to people with our ideas for space and helping develop a new environment and representing our voices. And Our Giant Leap is an initiative that was created last year to bring in front the problems faced by women in the space industry, because it's very easy to entice women into joining the industry. You just give them scholarships, you give them opportunities to join. But once women join the space industry, how do you keep them? How do you make the environment more sustainable for women? So that is what the Our Giant Leap initiative represents. And I'm very honored to present our partners for this webinar, Moon Village Association, and I hand the mic over to Aline to present a bit what the MVA stands for.
Thank you very much, Priyanka. So thank you everyone for joining our webinar today. I'm Aline Decazzi, rocket scientist at the European Space Agency and co-host for our webinar on behalf of the Moon Village Association. So the Moon Village Association is the international platform that aims to act like a global forum to foster collaboration worldwide and develop moon projects such as our payload project, which is a camera mounted on board of a moon lander to advance numerous scientific experiments. So I'm in charge of coordinating the activities related to education and outreach. Our vision here is to inspire and engage the public, including the youngest, toward a peaceful use of the outer space. And we also want to create a balanced community. And in this framework, we at MVA have created the initiative which is called Women on the Moon, to encourage women to participate in lunar exploration missions and activities. And this is a common vision that we share with SGAC, Our Giant Leap. And this is under this purpose that we decided to host this webinar together. I'm very pleased to welcome our Moon Village Ambassador, Barbara Imhof. Thank you, Barbara, for having accepted to share with us your inspiring work, your expertise in the lunar-related field, and your thoughts as a woman in STEM. For the audience, thank you, really, thank you very much. For the audience, I will just say that please be aware that I'm answering your question in the chat, the Q&A session, which is close by the screen share. So you can use it anytime to ask questions to Barbara during the webinar. And to finish this introduction part, please enjoy the Moon Village Association video sharing our passion for the moon exploration. I hope this will inspire you to be part of the next endeavor, showing a few examples of the work we do in the related lunar exploration field. Enjoy the video, enjoy the talk, and we wish you a good webinar. Thank you.
Sorry, I had an
Priyanka, are you still with us?
Okay, so I will share the video.
Oh.
Yeah, they're trying something. My internet is unstable. All right. Thank you for the video, Aline.
Thanks.
And yeah, law of Murphy, everything just going wrong at the same time. Anyway, So that was a presentation of Our Giant Leap and the Moonwalker Association. And now moving on to our distinguished guest, Dr. Imhof. Yeah, over to you.
Hi, Priyanka and Aline. Thank you for the introduction. Can you see my screen? Is it time for me now to start?
Yes. Yes.
Perfectly,
So,
thanks.
yes, just before you start, I would like to remind all our viewers that the Q&A session is running, so please send in your questions. And after each session, we are going to be forwarding your questions to Barbara so that she can answer some of them. Thank you.
Okay, well, then I guess I start. I'm very pleased to be invited here to this webinar. I'd like to talk a little bit about my background, where I'm coming from, but also the projects we are currently involved in, and then also maybe in a conversation, hopefully in a conversation with all of you and with Priyanka and Aline, move towards some issues which concern I would say, a gender, geography, and generation-based work life in the space business. So the title is Shifted Lunar Perspectives on Habitats and Women on the Moon. Well, basically my background lies in architecture. I was how can I say, I would always say bred in an art school, in a more art related school, in the University of Applied Arts in Vienna, but also at the Bartlett School in London, Bartlett School of Architecture, and at SGAC, the Southern Californian Institute of Architecture in Los Angeles. These are three schools with very famous teachers. I studied with a couple of them, more specifically with Wolf Brix of Coop Himmelblau. Coop Himmelblau are the, I would say, the radicals, the Rolling Stones of architecture. And so this is how my whole probably concept of life and also approach to architecture and to design has been shaped. But in my life, I was also always interested in technology. That probably stems from the fact that my parents always took me to the Technical and Science Museum in Vienna. Or that was also a place where we loved to go, my brother and myself. But I was drawn to technology, to new developments, and to the future. And my specific interest for architecture was how will we live in the future and what will the buildings look like? So I think this is what sparked my interest in space in the end, because you cannot think a future without space. You cannot think a future living without including the possibilities living on another surface on the moon or on Mars or in between somewhere. So this is why after my Master of Space Studies at the International Space University, I got together with Susmita Mohanty. She's originally from India, has worked for Boeing, and she was also awarded by the BBC, one of the most influential women of 2019. So she's a serial entrepreneur, but also a climate activist, and has run a couple of space businesses already. So we founded together, and then included Waltraud Hoheneder. Together as three women, we founded many years ago, more than 15 years ago, the office, a platform for space architecture, which was pretty unheard of at that time, and then three women in addition. So this is how it all started. But of course, we thought we were sort of talking to other people, and they said, well, what space in Austria at that time, because it's a originally Austrian company, needs is a systems group. So what is a systems group? It's an interdisciplinary group, but I'm not talking about a small interdisciplinary. I'm talking about a great interdisciplinary involving designers, engineers, scientists, so a very diverse spectrum, because this is probably how one can also tackle and approach as a small tiger team, small group, and a small company, projects, larger projects in the space business, but also, complement expertise which other businesses do not have. The space business in itself is a very interdisciplinary, on one level, interdisciplinary business, but it also is quite focused on engineering, more engineering than, the arts you find very rarely in there. So I'd like to present a couple of projects which all have to do with the moon, of course. This is what we are talking about today. It's I would say it's about starting. How do you start going to the moon? Probably you build something where you can simulate on Earth how it is to be on the moon. In our case, we were lucky. We got together with other partners under the lead of the International Space University and Space Application Services, COMEX, and other teams. We conceived project which is called SHE, Self-Deployable Habitat for Extreme Environments. And it was really built as a test bed for Earth to test future missions on the moon or on Mars for that reason. It's a deployable habitat. So what you can see here, that actually when you look on the right-hand side, this is the size of a container. So it's transportable to different building sites. Please imagine this to be closed off with a suit port. We'll see it later. This is still, these are pictures from the integration. And then it deploys slowly with 6 petals. You see smaller ones here, 2 smaller ones here, so there are 2 here, and then 4 bigger ones on this side into a double of what it was before. So it's altogether, it's 28 square meters. It has a volume of approximately 50 cubic meters, and it's for 2 people to live there for a mission of 2 weeks. So it's like a sort of first mission. When you look at this, you also have, it's fully furnished. There's a peek into that. We'll see later the interior. So all the furniture needs to be folded, deployed, stored, and configured. And then in the end, when you look at this, you hardly can stand in there. Actually, it looks a little bit like this. This is, this is the leftover interior in the middle of SHE. And it's an art piece. It's Juliana Sequeira Leite. She's a New York-based Brazilian sculptor, quite a famous artist. And she got inspired by SHE, by the project SHE, and worked with the leftovers, spaces, and really built this sort of sculpted replica. So this is always how we, the art is still part of us, and we also often connect to the artists to include them in projects. I'll show another example later. Back to the simulation habitat, SHE, you can see here, can be transported, but it's shaped as such that actually 2 back-to-back can fit into a large heavy lift launcher. So one can transport 2 of these habitats in one go, ideally. The launcher size is 6 meters in diameter. The interior, we saw different interior spaces. We had a workplace for 2 people, Here you see Waltraud Hohn, Eda, one of my two partners, and a new one, René Václavicek. Well, he has been in the company and built the company as well as we did for a long time. He has become managing partner only recently. So these are the workspace. This is the space for the hygiene facility. So the hygiene toilet is around the corner. This is the hygiene facility. And what you can gather from this picture is that there's a foldable wall which actually divides these two spaces, but is also the possibility to have this larger space when you work there, when you use it as a workshop, which you can do with these shelves. There are two crew quarters. Private crew quarters are very important, especially for long duration missions, but also, you know, in these like very small and limited spaces, it's quite important that people have their own room. That's also what Virginia Woolf in one of her books also found quite important. It's a room for on your own, basically. And you see also the beds are retractable. And in the middle, there's a communal space, a galley where the crew can meet. And here you see these two different crew quarters where we really used to also include lots of different lights. This is a virtual light which can change the light color, so you get different atmosphere. You can change the architectural atmosphere of that space quite easily. And there's some storage. Then we were lucky and we had the opportunity to take the She habitat into the Mars mission simulation of the project Moonwalk. We tested it 2 weeks in Rio Tinto, in the south of Spain. Rio Tinto is an acknowledged analog site, which means it's suitable to test Mars missions there because it's a sort of already extreme environment. And so whatever procedures, operations you develop, you can test it there quite well because it's it's a Mars analog on Earth. Moonwalk, so she was taken there and as part of Project Moonwalk, and Moonwalk was about human-robot collaboration, an astronaut with a small helper rover in comparison to astronaut-astronaut collaboration. So she served as the local Martian surface mission control. You see here the Capcom and the assistant basically. So this was the local Martian mission control. You also see that medical team that checks the simulation astronauts. And what we had was we used suit ports to step into the simulation spacesuit. Suit ports are very important, especially on the moon. They will be vital because the lunar dust is very abrasive, very sharp. And when you look at the Apollo astronauts, they were all gray all over their faces. So what actually happens is that the moon dust crawls into any kind of joint, mechanical joint. So and you really want to, you know, don't have the moon dust inside your habitat. So there is an option through a suit port, through a double lock. And when you step from, you know, inside, you only have the inside of the suit connected to the inside of the habitat and the outside stays outside. So this was a simulation of a suit port in these mission simulations. Here you see how then the astronaut rover, they were conducting fieldwork together. This was an astrobiology lab with a sign of life detector. Of course, in a real mission, this is only a simulated mission, you would never touch the samples with your own hands, even not with gloves. You would always have it in a sort of, you know, remotely operable glove box. You might see through, but you'll never be able to touch it, just because to stay safe, but also to, especially for Mars missions, to secure that the life, the biomes we carry with us, we are not putting on the samples to look for life, because then in the end, what we might find is just the life we brought there. Here are a couple of shots from the from the gesture-controlled rover and the human-rover interaction. The small helper rover can't carry a lot, can't do a lot, but what it can do is it can access sites and can traverse in terrain which is very hard for a suited up person to go to. So it's for scouting and for helping maybe for particular samples. Here you also can see me being a simulation astronaut. We also tested, compared the astronaut rover scenarios to the astronaut scenarios. And this is here underwater, and underwater we also collaborated with Sarah Jane Pell, who's an artist, performer, and occupational diver who was part of the moon mission simulation of Project Moonwalk underwater. So you see, it's a weave. It's a natural organic weave where we include a great interdisciplinarity. So this is preparing on Earth for the moon. So the next real step the International Space Station partners are doing is Gateway. Priyanka, do you like to ask a question?
So we do have a question for session 2, which was about your introduction. So what was your main inspiration to join the space industry and your space dream? And what advice would you give to people who want to join the space industry from a non-traditional, atypical background? What would be the first step?
Okay, so let me answer to the last question first. I think the advice would be for me, you know, architecture is a sort of bridge between the arts and technology, and really implementation and products and build stuff. So I think it depends on what kind of background that person has, but I think it's always good to have a sort of knowledge and background in technology, or in, I don't know, robotics, programming, in engineering, a sort of, one doesn't have to have a bachelor or master's in there, but it comes handy, and you might want to do a master's in one of these areas just to extend the knowledge and the expertise if you have let's say no knowledge. On the other hand, I have a lot of friends who are lawyers, and they are in the space business too. So I think there's a broad variety where people can engage, or medical doctors, or even journalists. So it really depends.
And we have another interesting question, which is, how do you start thinking like a moonwalker? How do you break free from thinking like a person living on Earth?
I think it has to do a lot with imagination. I'm not I always think of actors or actresses, but because they always have to get into their role, and thinking as a moonwalker is probably getting into a role a little bit. So how would people do that, or how would I do that? Reading books, or getting myself into, isolating myself. Maybe I have a guest professorship at the University of Kassel currently, and we do a space project. It's regarding Gateway, and one of the exercises was everybody needed to isolate themselves for 24 hours in the bathroom, and I think the what people gain from that, and when they observe themselves, that's quite interesting. I think also when you're trying to emulate the movements and what you can do and what not, maybe you just use the swimming pool, any public pool, and try out there a little bit how it is to float. Of course, 1.6G is not completely zero gravity, but it just to get a little bit a sense of all these different things.
Okay. Before moving on to the next session, we could have a final question, which is, so there are a lot of these analog missions coming up from MDRS or high seas. What is your opinion of these analog missions? Do you think they're useful towards developing our future lunar villages?
Well, I think we have to, absolutely. I think we have to do you know, analog missions, mission simulations of different kinds. I mean, they're the ones which are outside, they're in a sort of analog area, an area which is similar or has similarities with that particular extraterrestrial area or region, and which is on Earth. For example, Antarctica is also a good example. But there are many other areas also in the German Eifel area, for example, so they don't have to be that remote. And because we learn a lot of things there, and what we learn depends on the area and what we are investigating. On the other hand, there are also opportunities for indoor simulation spaces, as also a couple of space agencies are having or are building, for example, the lunar facility which ESA is currently building. So, and it really, but they all have their limitations, because, you know, only the perfect environment, that's in space, you have to go there. But I think learning and training, it's vital and it's important before going into space to do these simulation and analog missions.
We still have time for a couple of questions. So a question from Stephanie Paul, if I pronounce it correctly. What surprises you the most in analog missions? About
what surprises? I think everything which is unforeseen is sort of a surprise. And there was one, I can't remember, there was one cosmonaut, and he said, well, only when you have a problem you learn. So it's like, and I really like that, because it actually, it really speaks of that, yeah, that you have to take the problem as a challenge, and where you can learn something, which might be then, you know, very vital and you know, and necessary for survival later on. The learnings, the solvings of the problem. So Priyanka is frozen. Maybe I should go to something, to the next project. I'd like to introduce you to something we have. And Aline, you're still online. You probably can tell me, hear me when.
Yes, we have a lot of questions from the audience. Sorry. A very good one from Saeed Siran. When do you think she is going to be deployed in the moon? Or maybe what is the next step to use the project She to be representative of the moon environment?
Well, I think what we are currently trying together with the International Space University is to involve students in some kind of, yeah, how can I say, in some kind of exercises which could, so that we can plan the next steps. But in general, I think it can be used for short simulation missions, and it's open for everybody to apply or to, you know, show interest.
Very good for our audience. Thank you. So I think that for now we will stop with the questions. So yes, please go ahead.
Yeah, so what I'm showing here is really a snapshot of our current involvement in the IHAB. So you all know that Gateway is the next step of the International Space Station, I would say. The space station partners gathered. So we are involved in the interior configuration. This actually is a previous study we did for Airbus. And you will see that it's a small habitation module, but it has crew quarters. They are deployable, and because they have the Gateway is planned for 4 people, for a 4-person crew, for a mission duration of 1 month. And I think it's really time to promote the aspects of habitability and psychosocial factors to really learn in Gateway what it is to prepare for Mars, but also for long stays on the lunar surface. So this is all, it's basically a preparatory setting. And I think we have to be extremely thoughtful of how we are designing this habitation module, that it has sufficient space for everyone from the beginning. The requirements are very harsh. We're currently working for Thales Alenia with COMEX on this, but it's this is a precursor study, and you can already see that it's quite tight. So this is our task to, together with the engineers and with ESA, NASA, to come up with a good solution. Another project I'd like to quickly show, that is Regolite. It was an EU project under the lead of the German Aerospace Center in Cologne. And it's quite interesting because it's about solar sintering. It's about ISRU, in situ resource utilization. It's about using the sand and the sun on the moon to build habitats through additive layer manufacturing technologies. So how did we approach this? First of all, you have to know the moon is a very harsh environment. There's no atmosphere. So you need to protect humans from radiation and micrometeorites. And for this, you need probably 2 to 3 meters of sand or any kind of material, but you don't want to carry it or transport it there. You want to use it, what's already locally available. So we thought that, in this kind of vacuum shell here underneath that regolith layers, we'll have a sort of thin pressure envelope where people can live in. So this is a sort of a very short, this is what is sintering about. It's really concentrating the solar beam onto the sand to create, and in our case, interlocking 3-dimensional elements that can, be printed in that sense into sort of bricks, interlocking bricks, or also surface elements to create habitats, shelters, telescope, terrains for telescope, for lunar telescope, which is particularly interesting for science, or launch pads. On the moon, we really need to keep the dust out. And we also have to take into account that the launch pad needs to be far away from a settlement, so the dust doesn't, just go anywhere, because it just goes everywhere and into everything. So how did we approach this? It was really about proving that in a relevant environment, in a vacuum environment, here you see the small vacuum chamber, and here the 3D printing aperture, that lunar simulant sand, in our sense, can be printed and can be, put on together only by the concentrated beam. This is a previous experiment which showed that there's a XYZ table moving in all directions. the sand comes here from here, layer by layer, and gets sintered, so like glued together, and the next layer gets deposited when the shutter is closed. And the lights are xenon lights, and they simulate the lunar light. So this was a very small building volume, and for sure, if you want to look for the, for a really large brick, you have to look for larger volumes. Okay, so my computer is a little bit slow or fast, either way today. What you can see here is really how in a larger volume with a larger printer, where actually, this is here the Fresnel lens, you see that here. So that moves, and this is a solid table, which you could imagine later on when the technology is more advanced, could be sitting here on wheels. So it could be a rover sintering on the lunar surface. And this is one of the best pieces you can get out of it. You still see there's a lot of technology development necessary because it's bulging, but it has already quite a good integration and structural capacities. So we were designing based on these tetrahedrons. We were designing elements which with obtuse angles, so they fit the technology, but they also could be, put together into larger elements, building elements, so that they can actually comprise a setup where a self-sustaining envelope, shell, habitat could be built. Here's the surface battlement. This is how we envisioned the overall setup. So there are some hard shell modules. There's an inflatable and retractable scaffolding, and then in the middle, and here are the layers of the regolith and all of these printed pieces. They're quite a lot, but they're also reduced to the minimum, if I can say it like this. And in the middle of the arrangement, there's inflatable shell.
So unfortunately, we will not have time for further questions for this session. We should move on to the next session, which is what are your ideas on diversity and women in the sector of aerospace? And so I'll leave.
Yes, let me quickly show a couple of pictures I prepared, because I was starting and I was looking for that just to, so this is 1969. This is the last NASA astronaut selection, which was only male and only white male. And then the next one, this was in the dawn of the moon, the Apollo landing, of course. And that's why they all have these little references of the Apollo landing. And the next 9 years later, that actually had already, it was a larger group, but it was already slightly more diverse. Yeah, so it was 9 years later. It had, you see women, you see also African Americans, and the interesting thing is also the way they have, they have all their clothes. But when you then look at how they sit there, it's quite interesting to study, but I don't want to get into that. So that was also the time when Sally Ride, Judith Resnick, Annalie Fisher, and so on, they were all selected as the first women. This was their selection. But to be honest, that was, of course, after Valentina Tereshkova flew, 15 years earlier already. So in the end, it took 15 54 years to come from this, the Mercury 7 to the 2013 NASA astronauts, where we have, you know, an equal distribution of gender, not an equal distribution of geography, but at least of gender. So that's quite a lot. If you think 30 years or a generation, so it's it took 2 generations from the mid of 20th century to the beginning of the 21st century to come that far. So that is, Priyanka, maybe you can, the question is, I think more dedicated what to do.
There are going to be astronaut selections for ESA this year, apparently. And what would be your message for young girls dreaming of flying to this kind of call for astronaut applications?
Well, I mean, I think they should all apply, and they all should do their best to get into the last round. And with the European Space Agency, I have to say, the last round is always a political round. So if you're not from the main space countries in Europe, don't get your hopes high up, I have to say. Because your country has to support you. And if your country doesn't do that, then it's, but if you're, you know, German, French, or Italian, or maybe even, you know, Belgium, Dutch, Swiss.
Yes.
There are probably some good chances. And the you know, I'd encourage everybody to really, you know, sign up and go for it. But of course, to be honest, and there are so many other opportunities in the space business other than becoming an astronaut.
Right. And so we are 10 minutes before concluding the webinar session. Do you have any, so we're going to open up a general Q&A session. So before that, Barbara, do you have any messages you'd like to give to our audience? Something to take back?
Yes, well, I think there are a couple of, I prepared here these slides. I think we really have to dare, as women, we have to dare. There are a lot of preconceptions, and the worst ones are the ones we ourselves are caught in. So we have to overcome them, but we also have to support them. And I really have to say, you know, going back to this, when you look at that, do you think that 1959 there weren't enough suitable women available? It's a strategic choice. And this, you know, to come up with a selection like this, it's a strategic choice. So it's, nobody can tell me, oh, there weren't enough sufficient, you know, well-educated women. People have to make the choice. So it's up to us. It's up to all of us, men, women, everybody, to make a strategic choice to get us, you know, a distribution like this. So in that sense, it's about, you know, preconceptions. It's, you know, if I think it's also, you know, how can I say? There's this. I'm a reviewer for the European Commission for proposals, and I am part of a very specific team, and the head of that team, I have to say, he managed to call up all his friends, female, male friends, to ask them for reviewers, for female reviewers. And because of this one time, a little bit more effort engagement, now they have a huge database of female reviewers. And whenever I go there, at least 50% of the reviewers are female. Investors, venture capitalists, technologists, all different kinds of people, yeah, women. So I think people have to make strategic choices. We all have to make strategic choices. We have to promote women, we have to select them. And we also have to make slightly more efforts to get them on the stage, to get them in front, and to, you know, to create these databases where we can then also have immediately the, you know, 50-50 that the world's population reflected in each single little panel work, or wherever it is, stage. But at the same time, of course, we have to encourage people to, you know, create role models. It's always something about getting engaged yourself, and also finding maybe mentors and mentoring at the same time. Never getting lazy, networks, really supporting, but also, you know, stay true to yourself. It's really a lot also about the philosophy, integrity of the single person. And we are really in charge of designing our own life most of the time. And sit at the table. I really like that. You know, as women, we always tend to get into a room, everybody, you know, or, you know, and we always take a sort of side place. Why don't you just, you know, train it? Go into the room, take the middle seat on, you know, right in front at the table, and just see how that feels. And well, this is my last, it's from Oprah Winfrey. Step out of the history that is holding you back, step into the new story you're willing to create. I think that would be my last contribution before answering further questions.
That was a really nice quote. Thank you. Yeah, it's true that we have, as women, we have to take a stand. We have to sort of make place for ourselves. And even today, even though there are so many opportunities, I mean, look at the Zoom call. We are able to send people on the moon, but when it comes to just a basic Zoom, we still have technical glitches. So sorry about those from my side. And so despite all the things holding us back, we have to sort of, yeah, make our, go out and, yeah, ask for what we want. And despite all these inhibitions holding us back, I think you're very right that we have to cut through them and ask for our rights. So a few of our final questions that we have. One is from Lisa from MVA, who's asking something about the interdisciplinariness of space, about how culture has figured into your habitats.
How culture has, can you repeat again? Sorry,
how culture has figured into the design of your habitats. If you are inspired by human culture, or is it
that way. Yes, definitely. I think as an but that lies in the architecture background, that I mean, we are really designing for the human being, and we have to sort of, well, investigate the potential users. We have to put ourselves into their shoes, and all this, you know, look at the behavior, at the patterns, and also, you know, if they come from different cultures, I think, you know, it's also about learning about them, exposing ourselves to these different cultures, to be really able to understand for whom we are designing, for whom we are planning, and to broaden the personal horizon. I think that's the additional thing.
There's a question from Stephanie Pau again. So how much input do astronauts themselves give in designing such habitats? Do you also interact with a lot of astronauts to have their opinion?
Yes, we do. We always, well, we either ask them or they give us feedback, or they're part of the design team anyway. Yeah. So, and I think it's a mixture. I mean, what can I say? It's like medical doctors, architects, lawyers, you know, everybody has a specific expertise other people do not have. So I think it's about a collaboration and finding out, you know, what they need. but also staying true to the architectural expertise one has and combining them into a good design, which is useful, functional, but also aesthetically pleasing.
Okay. And there's a question from Mohammed, yes, Dani. Is it being planned to extract oxygen from regolith, or do you think it's taking it from Earth is a better or cheaper option?
No, I think it's planned to do that. But to be honest, I think there are some technical people on the panel. Maybe the president of the Moon Village Association, Giuseppe Rivaldi, he's in a much better place to answer that question than myself.
Okay. A question from Rox Sesko, layer by layer, or he's asking why use bricks?
Say again, sorry, you were breaking up.
He asked if you are considering sintering the radiation shield directly layer by layer, because it was in the promotional video of Isa's Moon Village.
Yeah, I think there are different techniques, I would say. There's also contour crafting, which involves a lot of chemicals, which have to be taken on Earth. There's also the option which was promoted through ESA and Foster and Partner, but they all involve additional chemical substances which need to be taken from Earth, and sometimes in a quantity of 1:1. One part chemicals, one part regolith. But there also, I think, while we need to investigate the capacities, potentials of regolith a little bit more, because we can also get a lot of maybe polymers also from the regolith that could help us make better quality material. I think there's a lot, all these ISRU activities, they are quite vital to find out how we can really actually live on the moon with in situ resource utilization.
Okay. Unfortunately, we've run out of time, but we had a lot of interesting questions coming up. We would be putting the recording online for the rest of the viewers to see who could not join us. We would also be writing a report on this webinar. So most of the questions that were not answered, we tried to have them answered for the newsletter. So do keep a lookout for our newsletter from the SGAC. And do connect to our networks, reach out to the Moon Village Association, to the SGAC, to Our Giant Leap for all your further questions, and obviously to Barbara as well.
Thank you.
And this was really nice, Barbara. Thank you for finding time for the webinar. And I hope everyone learned something new about interdisciplinary approach to space, about diversity and the importance of it. And I wish you all a very good evening, and thank you for joining us.
Thank you for the invitation to Space Generation Advisory Council and to the Moon Village Association. Thank you, Priyanka. Thank you, Aline.
It was a pleasure. Okay.
Bye.
Bye.
Bye.